Yo, we are back. It was quite complicated because I was quite busy the previous week because of work, and last weekend, I couldn't also stream because my leg was hurting and so I couldn't move properly. But now, folks, we are back, and I think in the next 2 weeks I will stream every day. Every day. So yeah, I'm just planning to continue learning Rust because we stopped at 4.3 and yeah, slacking quite a lot previous week. So um, yes, and one of our main problem too is that we didn't code many lead code problems. So like I feel like what's nice with these coding problems is that it forces you to learn like the syntax of the language you are using for solving the problem. So I think it's a great way to learn a new language, or at least to be comfortable in it. So yeah, I'm planning to solve every problem we missed in the last 2-3 weeks, starting from the 1st of February. Oh fuck, I'm not showing my screen. That's crazy actually. That's crazy. Yeah. Twitch stream titles. Rust grind the programming language book. How do I update the stream title? Okay, pretty easy actually. Perfect. So yes, I'm planning for the next week, or yeah, the next 2 weeks to stream every day. Between 1 hour and 3-4 hours, and I hopefully 5-6 hours during the next weekend per day. But let's see. So we stopped at 4.3, the slice type, and now we are continuing on the using structs to structure related data chapter. A struct or a structure is a custom data type that lets you package together and name multiple related values that make up a meaningful group. If you are familiar with an object-oriented language, a struct is like an object's data attributes. In this chapter, we will compare and contrast tuples with structs to build on what you already know and demonstrate when structs are a better way to group data. We will demonstrate how to define and instantiate structs. We will discuss how to define associated functions, especially the kind of associated functions called methods, to specify behavior associated with a struct type. Structs and enums, discussed in chapter 6, are the building blocks for creating new types in your program's domain to take full advantage of Rust's compile time checking. That sounds good. So if I reread, a struct is like objects data attributes. So it's just the same thing as data attributes. It's not the same as an object, right? Because from what I remember, when I read a bit about Rust is that it doesn't have a class feature that you would, for example, see in Java or JavaScript or any language that has a which is like a bit hoop focused. So yes, let's see. Defining and instantiating structs. Structs are similar to tuples, discussed in the tuple type section in that both hold multiple related values. Like tuples, the pieces of a struct can be different types. Unlike with tuples, in a struct you will name each piece of data so it's clear what the values mean. Adding these names means that structs are more flexible than tuples. You don't have to rely on the order of the data to specify or access the values of an instance. I see. To define a struct, we enter the keyword struct and name the entire struct. A struct's name should describe the significance of the pieces of data being grouped together. Then, inside curly brackets, we define the names and types of the pieces of data, which we call fields. For example, listing 5.1 shows a struct that stores information about a user account. To use a struct after we have defined it, we create an instance of that struct by specifying concrete values for each of the fields. We create an instance by stating the name of the struct and then add curly brackets containing key value pairs where the keys are the names of the fields and the values are the data we want to store in those fields. We don't have to specify the fields in the same order in which we declare them in the struct. In other words, the struct definition is like a general template for the type. And instances fill in the template with particular data to create values of the type. For example, we can declare a particular user as shown in listing 5.2. Okay. I'm now wondering how is the struct type converted in like the low level code. I guess it will be like similar to a tuple and it will assign for each attribute like an index and when you use for example user one dot email, it will transform this into an index way. So you would have this would be transformed to user one dot one or a dot two or a dot zero depending on which index is the field transformed to. But yeah, I'm not sure actually, so let's see. To get a specific value from a struct, we use dot notation. For example, to access this user's email address, we use user1.email. If the instance is mutable, we can change the value by using the dot notation and assigning into a particular field. Listing 5.3 shows how to change the value in the email field of a mutable user instance. Changing the value in the email field of a user instance. Okay, so you can add the mute keyword on the struct, okay, and then mutate it. Pretty simple so far. Note that the entire instance must be mutable. Rust doesn't allow us to mark only certain fields as mutable. As with any expression, we can construct a new instance of the struct as the last expression in the function body to implicitly return that new instance. Listing 5.4 shows build user function that returns a user instance with the given email and username. Okay. the active field gets the value of true, and the sign in count gets a value of 1. Okay. I'm not sure how this pattern is called, but hello, how are you? Not long ago, I started learning a new language called Rust, and the truth is, I feel very challenged by learning it. I come from a high level language, Python. I wanted to ask which language is more suitable for cyber and information security, WebPT, Rust, or Golang. Let me firstly search what is WebPT, like I'm not sure what it refers to. Information security. Like personally, I've used multiple languages before. Like I've used Python, but I've also used JavaScript, Java. I did some C, but not so much. Web pen testing. Okay, web pen testing. Okay. There are a lot of also work going on in that area to make sure that the contracts that are written are secure. And so if you know Solidity, you will be able to probably to then understand the contracts written in Solidity and see if they are safe or not. Yes, and for Rust and Golang, I'm not sure if there are really like a big community related to cybersecurity. Probably, that I'm not aware of. So yes, to be fair, like just pick one language, try to see what you can work on in related to cybersecurity, and then if it doesn't suit you, you can try to pick another one. I know it's like the answer is like a bit bad because I'm saying you to basically just pick one language, even though it's probably not the best, and see what you can do with it. But I think it's a pretty good mentality because it forces you to really like keep learning and pushing yourself to learn new technologies and new languages. Hope the answer was a bit useful to you at least. All right, let's go back to Rust. Listing 5.4 shows a build user function that returns a user instance with the given email and username. The active field gets the value of true and the sign in count gets a value of 1. Build user email string username. Alright, so this pattern seems... Yeah, so I was asking if this pattern of having a function that will return you a struct is really common or not. It seems to me that it's like a factory, and so it might be useful to have this. Like for example, I know that for example in Java you would have the factory pattern used quite frequently. Let's ask ChatGPT what is the factory pattern? What is the factory pattern in software development? Okay, I think it will the answer will be too long, but basically it's a function that returns an object, and it seems similar to this because instead of returning an object, we return a struct. So for me, it makes sense that this is similar to a factory pattern. It makes sense to name the function parameters with the same names as the struct fields, but having to repeat the email and username fields, names, and variables is a bit tedious. If the struct had more fields repeating each name, would get even more annoying. Luckily, there is a convenient shorthand using the fields in each shorthand. Because the parameter names and the struct field names are exactly the same in listing 5.4, we can use the fields init shorthand syntax to rewrite build user so that it behaves exactly the same but doesn't have the repetition of email and username as shown in listing 5.5. Okay. Okay. Here we are creating a new instance of the user struct which has a field named email. We want to set the email field's value to the value in the email parameter of the build user function. Because the email field and the email parameter have the same name, we only need to write email rather than email. Creating instances from other instances with structs update syntax. It's often useful to create a new instance of a struct that includes most of the values from another instance, but changes some. You can do this using struct update syntax. First, in listing 5.6, we show how to create a new user instance in user2 regularly without the update syntax. We set a new value for email, but otherwise use the same values from user1 that we created in listing 5.2. Using struct update syntax, we can achieve the same effect with less code as shown in listing 5.7. I see. This reminds me the spread operator in JavaScript. Mr. Bog, how are you doing, Mr. 8? Or just 8? Getting by what? Getting by, maybe it's an expression that I don't understand. Getting by me. I see. Then that's good. When are you starting your internship at Amazon? I don't know the timeline for you. 2 months from now. That's good actually. So you will start in April, mid-April. So it would May. Wait, you said 2 months. We are in February. And do you already know the team you will join? The code in listing 5.7 also creates an instance in user2 that has a different value for email but has the same values for the username active and sign-in count fields from user1. Yes, that's pretty easy to understand if you know what's the spread operator in JavaScript. No, but I know I will be part of AWS. Nice. So you might actually use Rust because I know that AWS is embracing Rust. Embrace. Fuck me, bro. Rust. Why AWS loves Rust and how we would like to help. Like, actually, I think Who is the creator of Rust? Voids. What do you mean by voids? There are no Rust founders? Or is, oh, okay. Graydon. Like I know that one of the main library in Rust is called Tokyo, and the creator of Tokyo is like a principal engineer at Amazon. Tokyo Rust programming founder, Carl Lurch. And like this guy is cracked actually. Carl Lurch. Let me check. Yes, principal engineer, AWS. Chad. I think he's a Chad, yes. Let's check if he is coming from a top tier university or not. Portland State University. Doesn't look like a top uni, but he did a bachelor's in mathematics and not in CS, so I guess probably it's similar in terms of prestige. Portland State University. All right. The dot user must come last to specify that any remaining fields should get their values from the corresponding fields in user 1. But we can choose to specify values for as many fields as we want in any order, regardless of the order of the fields in the struct's definition. Note that the struct update syntax uses equal like an assignment. This is because it moves the data, just as we saw in the ways variables and data interact move section. Okay, yes. In this example, we can no longer use user1 after we creating user2 because the string in the username field of user1 was moved into user2. If we had given user2 new string values for both email and username, and thus only used the active and sign-in count values from user1, then user1 would still be valid after creating user2. Let me read because I'm not sure I have fully grasped the logic. If we had given user2 new string values for both email and username, and thus only use the active and sign-in count values from user1, then user1 would still be valid. I see. So if we only had if we only provided basic data types like integers and booleans, then the variable user1 would not be moved to user2 and would still be living itself. Okay. The types of active and sign-in count are types that implement the copy trait, so the behavior we discussed in the stack only data copy section would apply. Using tuple structs without named fields to create different types. Rust also supports structs that look similar to tuples, called tuple structs. Tuple structs have the added meaning the struct name provides, but don't have names associated with their fields. Rather, they just have the types of the fields. Tuple structs are useful when you want to give the whole tuple a name and make the tuple a different type from other tuples, and when naming each field as in a regular struct would be verbose or redundant. So I think this is what I was talking about earlier. that internally, when you use a normal struct with fields inside it, it would be converted to something similar to a tuple, and each time you use dot the attribute name, it will be converted to an index. Interesting. Color 000. That's actually a very useful use case and feature, because there are many use cases where this would be very useful to have a name and not just a bunch of numbers. Color points. Okay. Note that the black and origin values are different types because they are instances of different tuple structs. Each struct you define is its own type, even though the fields within the struct might have the same types. For example, a function that takes a parameter of type color cannot take a point as an argument, even though both types are made up of 3 ISRG2 values. Otherwise, tuple structs instances are similar to tuples in that you can destructure them into their individual pieces. And you can use a dot followed by the index to access an individual value. Nice, okay. Unit-like structs without any fields. You can also define structs that don't have any fields. These are called unit-like structs because they behave similarly to unit-like structs without any fields. I think that's the return type when you don't return nothing, right? Let me double check. Carg renew tuples. So let's say I have a function fn nothing. What's the return type of nothing? And if I remove this, do I also get nothing? That's the type we are getting, right? It's the same type as this. The unit type that we mentioned in the tuple type section. Let me come back actually because I'm not sure. The tuple type, a tuple is a general way of grouping, yes. Also, I will come back in 5 minutes. I need to complete something I'm remembering. So see you in 5 minutes. Unit-like structs without any fields. You can also define structs that don't have any fields. These are called unit-like structs because they behave similarly to nothing. The unit type that we mentioned, so So there isn't any null type in Rust? Wait. I guess that's one of the basic knowledge that I should have. Rust can never be null. Although Rust does not have null but provides an enum option which can encode the concept of a value being present or absent. My client implements two methods new to instantiate the struct and connect to open. I want to set the con field in the new method to some default value. In Go I can do something like con nil, but it doesn't work here. I try default value too. But that trait isn't implemented for TCP stream. How should I set it to a default value? Type option represents an optional value. Okay. Noun. Okay. Match results. But wait, what's the difference between non-Rust? What are some and none? Got it. Got it. You give a field the type option TCP stream to indicate that it might not be there, none, or be a valid value, some TCP stream. Option TCP stream, if you would like to keep this call pattern, an option expresses the possible lack of a value. Okay, that sounds good. We will discuss traits in chapter 10. Here is an example of declaring and instantiating a unit struct named always equal. Always equal. These are called unit-like structs because they behave similarly to the unit type that we mentioned in the tuple type section. Unit-like structs can be useful when you need to implement a trait on some type but don't have any data that you want to store in the type itself. Unit-like structs can be useful when you need to implement a trait on some type but don't have any data that you want to store in the type itself. Interesting. Let me actually search what is a trait in Rust. A trait tells the Rust compiler about functionality a particular type has and can share with other types. Traits are an abstract definition of shared behavior amongst different types. So we can say that traits are to Rust what interfaces are to Java, or abstract classes are to C++. Okay. Yes, so I remember that when the book was mentioning the copy trait, I guess it would be the same as copy interface Java, clonable interface. Okay, so I guess it would be the same as the clone function in Java. Clone deep. Okay. To define always equal, we use the struct keyword, the name we want, then a semicolon. Wait, the name we want, then a semicolon. No need for curly brackets or parentheses. Then we can get an instance of always equal in the subject variable in a similar way, using the name we defined without any curly brackets or parentheses. Imagine that later we will implement behavior for this type such that every instance of always equal is always equal to every instance of any other type. Perhaps to have a known result for testing purposes. We wouldn't need any data to implement that behavior. You will see in chapter 10 how to define traits and implement them on any type, including unit-like structs. Ownership of struct data. In the user struct definition in listing 5.1, we used the owned string type rather than the NSTR string slice type. This is a deliberate choice because we want each instance of this struct to own all of its data and for that data to be valid for as long as the entire struct is valid. It's also possible for structs to store references to data owned by something else, but to do so requires the use of lifetimes, a REST feature that we will discuss in chapter 10. Lifetimes ensure that the data referenced by a struct is valid for as long as the struct is. Let's say you try to store a reference in a struct without specifying lifetimes, like the following. This won't work. Okay. Email username. The compiler will complain that it needs different specifiers. So a specifier is just the data type specifier, right? It needs lifetime specifiers, wait. What is a lifetime specifier in Rust? In Rust, a lifetime specifier is a way of indicating the lifespan of references to data within a program. Lifetime ensure that references to data remain valid for the duration of their usage and prevent data from being used after it has been freed. Lifetime specifiers are denoted by the backtick symbol and appear in the function or method signature. For example, the following function takes a reference to an integer with the lifetime a. The lifetime specifier a indicates that the reference x is valid for the lifetime. The lifetime must be smaller than or equal to the lifetime of the data being referred to. This means that the reference x cannot outlive the data it points to. Lifetime elision rules are also applied in Rust, which are a set of default lifetimes assumptions that the compiler makes when lifetime annotations are not explicitly specified. that the compiler makes when lifetime annotations are not explicitly specified. These rules allow the programmer to write code without explicit lifetime annotations in many cases. However, it is good practice to explicitly annotate lifetimes, as this makes the code easier to understand and less prone to bugs. What is a lifetime in Rust? That's probably the first question I should firstly ask before asking what is a lifetime specifier. A lifetime refers to the lifespan of a reference to data within a program. A lifetime defines the scope in which a reference to data is valid and can be used. The purpose of lifetimes is to ensure that references to data remain valid for the duration of their usage and prevent data from being used after it has been freed. Lifetimes are used to prevent dangling pointers, which are pointers that reference data that has been freed or reallocated. This is what we remember from the ownership section of the Rust book. When a reference to data is created, the lifetime of the reference is associated with the lifetime of the data it refers to. This ensures that the reference remains valid as long as the data is valid and prevents the reference from being used after the data has been freed. Lifetime are typically specified using lifetime annotations in the function or method signature. For example, the following function takes a reference to an integer with the lifetime a. This ensures that the reference remains valid as long as the data is valid and prevents the reference from being used after the data has been freed. Yeah, it is still confusing to me, but I guess it will be more clear when I will read the chapter on lifetimes. A Rust feature that we will discuss in chapter 10. Lifetime ensures that the data that the data referenced by a struct is valid for as long as the struct is. Let's say you try to store a reference in a struct without specifying lifetimes. Like the following, this would work. How to fix these errors so you can store references in structs, but for now we will fix errors like these using owned types like string instead of references like endstr. Okay. Sounds good. Question 1. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. So we have a struct points with two fields, x and y, that are of type signed 32. Signed integer of 32 bits. We create an instance of points that is mutable. We increment the field x, and then we create a new instance of points called b that is redefining y to 1 and getting x2 from a x that is equal to 2. And from what we remember, this would be if this would fail if we used complex data types such as strings or references, but since this is basic data types, it should compile actually, and it will print 2, right? X is equal to 2. Determine whether the program will pass the compiler. If it passes, write the expected output of the program. If it were executed, okay. It's the same. So we have a struct point with 2 fields, x and y, that are of type signed integer of 32 bits. Line 7, we define an instance of p that is mutable. Let x is a mutable. Wait, what? What's this syntax? I'm not completely sure what it means. Px and py. I would say that there isn't any problem, but I don't have any argument to justify it. Like, this syntax seems a bit strange to me, but it should work, I think. And so, actually, I would say it's compiling, but I would like to see why it would compile or not. All right, yes, we were right. But this is strange actually for me. Did we see something like this or not? Okay. We didn't see ampersand mute operator before in this chapter. All right. Sounds good. So we completed the section 1 of the chapter 5. So I think I will just try to finish this chapter, and then I will solve the daily LeetCode problem, which is minimum fuel cost to report to the capital, and then we will probably solve this problem. If we have time, you are given 2 arrays. Or actually, I think actually this one I've missed too. Like, I've read the statement for as far from land as possible. But yes, let's see. Firstly, let's finish the chapter. Or actually, let's read the problem statement, because I don't think I've read this one before. You are given an integer n, the number of nodes in a directed graph, where the nodes are labeled from 0 to n minus 1. each edge is red or blue in this graph, and there could be self-edges and parallel edges. Self-edges and parallel edges, okay. You are given two arrays, red edges and blue edges, where red edges indicates that there is a directed red edge from node A1 to node B1 in the graph, and blue edges indicate that there is a directed blue edge from node U to node V in the graph. Return an array answer of length n, where each answer x is the length of the shortest path from node 0 to node x, such that the edge colors alternate along the path, or -1 if such a path does not exist. It's the shortest path. It's probably related to BFS then. Okay. Yeah, sounds like a BFS problem. Not too bad in my opinion, but I might be wrong, so let's see. 0, 1, -1. Yeah, I would probably just do a BFS on where I started on X, where I would output 0 to n -1. To node x. Of the shortest path from node 0 to node x. Oh wait, actually I can just, sorry, so I should do the BFS from 0 and yes, that's it. Yes, that's actually a pretty interesting problem, but yeah, quite lacking this these days, so didn't solve it earlier. And this one is also a BFS, pretty interesting one. It's a multi-BFS problem that we'll also solve it tomorrow if we solve the first last two ones today. Okay, so let's keep focus on reading the rest book and not be distracted by LeetCode problems. An example, program using structs. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle. We will start by using single variables and then refactor the program until we are using structs instead. Let's make a new binary project with cargo called rectangles that we will take the width and height of a rectangle specified in pixels and calculate the area of the rectangle. Listing 5.8 shows a short program with the one way of doing exactly that in our project's main.rs. Okay, so let's do this. Cargo new rectangle. Main.rs. The area of the rectangle is. Wait, I'm just trying to remember also how to do a for loop in Rust. So I think it's for I in 110 print ln I. Got it. Println is a macro. f area with height. Okay. And so if I run this program, cargo run, the area of the rectangle is 1500 square pixels. That is correct. 30 times 50 is equal to 1500. This code succeeds in figuring out the area of the rectangle by calling the area function with each dimension, but we can do more to make this code clear and readable. The issue with this code is evident in the signature of area, fn area with height. The area function is supposed to calculate the area of one rectangle, but the function we wrote has two parameters, and it's not clear anywhere in our program that the parameters are related. It would be more readable and more manageable to group width and height together. We have already discussed one way we might do that in the tuple type section of chapter 3. Okay, so let's do the dumb way. So let's take, or actually let's just follow the section refactoring with tuples. Okay, so let's rec to 30, 50. Wait, what did I do? Control point, interesting, extract into variable. Oh wow. Extract into function. Didn't know that this command would be available. Okay, so let's just comment this so far. Dimensions u32, u32, and it will also return a u32. Dimensions dot 0 times dimensions dot 1. Println dimensions. Wait, it's right actually. Okay. Sounds good. In one way, this program is better. Tuples let us add a bit of structure, and we are now passing just one argument. But in another way, this version is less clear. Tuples don't name their elements, so we have to index into the parts of this tuple, making our calculation less obvious. Mixing up the width and height wouldn't matter for the area calculation, but if we want to draw the rectangle on the screen, it would matter. We would have to keep in mind that width is the tuple index 0 and height is the tuple index 1. This would be even harder for someone else to figure out and keep in mind if they were to use our code. Because we haven't conveyed the meaning of our data in our code, it's now easier to introduce errors. Refactoring with structs, adding more meaning. Okay, let's do it. Static rectangle with, which will be of type u32. Height u32. Syntax error, missing type, static const. Wait, what? I'm trolling, bro. It's a struct, not static. Alright. And what if I remove a comma and I'm running the format rockets, adding a comma? Let rec is equal to 30, 50. Missing, okay, I forgot that I need to add the attribute names. Height. And I guess that you can also change the order, it doesn't matter. Rec. Rectangle. Rectangle dot height times rectangle dot width. Yeah, I could use the automatic completion from VS Code, but I want to type everything from scratch. Type everything, okay. Perfect. Here we have defined the struct and named it rectangle. Inside the curly brackets, we define the fields as width and height, both of which have type u32. Then in main, we created a particular instance of rectangle that has a width of 30 and a height of 50. Our area function is now defined with one parameter, which we have named rectangle, whose type is an immutable borrow of a struct rectangle instance. As mentioned in chapter 4, we want to borrow the struct rather than take ownership of it. This way, main retains its ownership and can continue using rect1, which is the reason we use the ampersand in the function signature and where we call the function. Let's do it. Ownership and borrowing. Which is why you often see borrows of structs. Okay. Adding useful functionality with derived traits. It would be useful to be able to print an instance of rectangle while we are debugging our program and see the values for all its fields. Listing 511 tries using the println macro as we have used in previous chapters. This won't work, however. Really? Let's actually try. Println rec1 is rec. Rectangle doesn't implement display traits. Display trait is not implemented for rectangle in format strings. That's okay. I hate this part. The okay, this part of the error message without the line break. Okay, but I guess it doesn't matter. Attempting to I guess just to have everything on one line and not having everything added at the bottom, because if the error message is 10 lines of code, you would need to move everything 10 lines at the bottom. When we compile this code, we get an error with this core message, cargo check. If we continue reading the errors, we will find this helpful note. Yes, let's try it. The println macro call will now look like println, putting the specifier. That's actually what would it do with rectangle doesn't implement debug. The trait debug is not implemented for rectangle. So okay, so I guess when you use this, it's a different trait. The print uses a different trait, the trait debug instead of the trait display. But again, the compiler gives us a helpful note. Okay. Derive debug. Rust does include functionality to print out debugging information, but we have to explicitly opt in to make that functionality available for our struct. To do that, we add the outer attribute hashtag bracket derive debug. Okay. Hashtag derive brackets. Wait. It's inside derive debug. I see that there is also the trait clone partial serial display. Display cannot find derive macro display in the scope. Interesting. So now if I run cargo check, cargo run, rec1 is rectangle with 30 height 50, my bad. Nice typo. Which typo did I do? When was the message sent? Damn, I cannot see on Twitch. The struct static thing. Oh, I'm them, guy. I'm them. That's it. Yeah, struct static. Yeah, I'm not sure why I've used the keyword static instead of struct. Okay, let's go back to the Rust book. Okay, so you can derive traits using using this statement or this expression. I mean, I should not call this expression or statement because they have specific meanings in Rust. It's probably more annotations, yes, annotations. The outer attribute, that's how they call it, outer attributes. Now, when we run the program, we won't get any errors and we will see the following outputs. Okay. Notes. Wait, let me read because this is probably useful in development. It's not the prettiest output, but it shows the values of all the fields for this instance, which would definitely help during debugging. when we have larger structs, it's useful to have outputs that's a bit easier to read. In those cases, we can use column hashtag question mark instead of column question mark in the println string. In this example, using the column hashtag question mark will give us this. Okay. Rec1 is rectangle. Okay, so it's giving the variable name, the struct type, and the attributes inside. Got it. Another way to print out a value using the debug format is to use the dbj macro, which takes ownership of an expression, as opposed to println that takes the reference, prints the file and line number of where that debug macro call occurs in your code, along with the resulting value of that expression, and returns ownership of the value. Okay. So let's say that let rec is equal to debug of rec. Wait. str unknown. Okay, so I probably don't need to have a message like here for println. Interesting. So it's the same as the column hashtag question mark in brackets in the println macro, but we'll also get the file name and the line. Okay, as explained here. Calling the dbj macro prints the standard error console stream stgr, as opposed to println, which prints to the standard output console stream. We will talk more about stgr and stgout in the writing error messages to standard error instead of standard output section in chapter 12. So this is an outer attribute, and it's like an annotation to derive traits from somewhere. Here's an example where we are interested in the value that gets assigned to the with fields, as well as the value of the whole struct in rect1. With debug 30 times scale. Interesting. And rect1 30 times scale is equal to 60. Interesting. So if we use the dbj macro, we don't just get the expression from the we just don't get the value from the expression, but the expression itself plus the value in the console. Interesting. I'm actually wondering how it does, like how it is done internally under the hood. Maybe it's just some specificities of macros where basically you can get the expression. Macros are cool magic. Okay. Can see from that, yes. So we have the. So let me try to recap and synthesize. So I can print using this. It will give me a pretty value. If I also add a hashtag, it will give me a pretty value with the variable name and the type if it is a struct, for example. And then I can use gbug, the gbg macro that will give me the same thing as the column hashtag question mark in a println, but with the file name and the line where the gbug macro is used. Okay. We can put the gbg macro around the expression search timescale, and because dbg returns ownership of the expression's value, the with field will get the same value as if we didn't have the gbg macro called there. Okay. We don't want gbg to take ownership of rect1, so we use a reference to rect1 in the next call. Here is what the output of this example looks like. We don't want gbg to take ownership of rect1, so we use the ref. Okay. Makes sense. We can see the first bit of output came from main.rs line 10, where we are debugging the expression search timescale and its resulting value is 60. The debug formatting implemented for integers is to print only their value. The gbg macro call on line 14 of main.rs outputs the value of rect1, which is the rectangle struct. This output uses the pretty debug formatting of the rectangle type. The dbg macro can be really helpful when you are trying to figure out what your code is doing. Okay. Is it better than using a debugger, like the Rest debugger, or like, to be fair, if I need to debug a code in another language like Python or even JavaScript, if it's not something related to React or Svelte, I would just pin the line that I want to debug, and that's it. Actually, let me try and see if I can use a debugger. Rest and friends. 2.8 million. Install. Mandelbrot. I use both print and debugger. No debug. So you only use the println macro, if I understand you correctly, or you also use the debug macro, if it makes sense. Or you always use the debug macro and never the print macro. Okay, so you use the println macro, debug macro, and debugger. It always depends on what I wanna do. So when would you use the debugger compared to just some prints? Like, I guess it makes sense if you, like, what I would do, for example, in Python when I'm coding some Python is to use the debugger if I have some for loops or and I need to really like see the mutations made in the for loop, or if I want to follow the order of execution. Like, let's say I'm doing some recursive calls, then probably I would usually println and randomly debug. Interesting. What do you mean by randomly? We can see the first bit of output came from main.rs line 10, where we are debugging the expression search timescale. Okay, I think I have read this part. In addition to the debug traits, Rust has provided a number of traits for us to use with the derive attribute that can add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C. So we have seen that there is also the clone trait, if I'm not mistaken. And I guess the copy one too. Okay. Let me check the Appendix C, and then after I will also try to run this code LLGB debugger. Well, randomly, I don't have a schema when I use debug macro, the debug macro, really, only when I feel like it. Okay. To be fair, like I don't see, actually maybe it's just because I didn't write a lot of Rust, but I don't see if it really adds a value to use a debug than just the println macro. Like I don't see where it's useful to, okay, maybe actually it might be useful to get the file name and the line number. Like actually I don't even know like how do you have like multiple Rust programs and export some values. I hope to learn this quite soon. Appendix C, derivable traits. In various places in the book we have discussed the derive attributes, which you can apply to a struct or enum definition. The derive attribute generates code that will implement a trait with its own default implementation on the type you have annotated with the derive syntax. In this appendix, we provide a reference of all the traits in the standard library that you can use with derive. Each section covers what operators. Okay, I just want to get a quick look because it's mentioned that we will see the derive attributes again later in the book, so probably it's not the right moment to check the appendix. We will cover how to implement these traits with custom behavior as well as how to create your own traits in chapter 10, yes. There are also many attributes other than derive. For more information, see the attribute section of the Rust reference. Our area function is very specific. It only computes the area of rectangles. It would be helpful to tie this behavior more closely to our rectangle struct because it won't work with any other type. Let's look at how we can continue to refactor this code by turning the area function into an area method defined on our rectangle type. Okay, so let's start the quiz. Question 1. Determine whether the program will pass the compiler. If it passes, write the expected output of the program if it were executed. So we have a struct rectangle with two fields, width and height of type unsigned integer with 32 bits that has the derived debug traits. We create a rectangle inside rect1 in the main function, and we get the output of the function area that takes rect1, and it returns the area. And I think this will not compile because rect1 will be moved to area, to the area function, and so it cannot be used anymore. So I will say it's not compiling. Which statement best describes a difference between the display and debug traits? Display cannot be implemented for structs, while debug can be implemented for structs. This is false, because we have seen that in one of our error messages that we could have added the display traits for a structure. Display is for printing values to the console, while debug is for viewing values in a debugger. That's also not true. Actually, I'm not sure. There is no difference. Display and debug are aliases for the same trait. No. Doesn't make sense to have two names for one trait. Display is for presenting values to an end user, while debug is for developers' internal use. Okay, I guess that's for this case. And it would actually make sense. Oh wow. Display is for printing values to the console, while debug is for viewing values in the debugger. Which statement best describes? Okay, so let's redo the quiz. Like, maybe I'm wrong about this. There is no difference. Display and debug are aliases, but no, because they don't have the same behavior, so it cannot be this. Display cannot be implemented for structs, while debug can be implemented for structs, and this is also false. I guess it's the fourth possible answer, but it seems a bit weird actually. So okay, display is for presenting values to an end user, while debug is for the developer's internal use. Okay. To be fair, this answer seems a bit unclear to me, because you usually print things only to, like, only developers print things, and if you use let's say a CLI that is getting prints from a Rust execution, then it's usually also a debugger, a developer, or someone similar to this that will use the tool or the CLI that you build. But that's still good to know. Okay, so let's go to the section 3 now. Method syntax. So I guess it will be the same as like implementing methods for classes in other languages like Java. Good points actually. About println that will only be used by developers, or you mean that it's a good point, like the explanation here is a good point? Yes. But yeah, to be fair, your point about only developers printing, yeah, I mean, I can see like a use, like, not a use case, but an ever, not a use case. What was the name in English? A state where non-developers would use a tool that has a console and that would get prints, but it's very, like, it's a minority state that you would not see anywhere else. Like, for example, when you like print in JavaScript or Python or Java, it's only for developers. It's not for users. Like, who is going to the console here and looking at what is in the dev console. All right, defining methods. Let's change the area function that has a rectangle instance as a parameter, and instead make an area method defined on the rectangle struct as shown in listing 5.13. Okay, so to implement a method, you prefix the struct name with implement, and then you define all the functions you want to make for the struct. Okay. To define the function within the context of rectangle, we start an implementation block for rectangle. Everything within this implement block will be associated with the rectangle type. Then we move the area function within the implement curly brackets and change the first, and in this case only, parameter to be self in the signatures and everywhere within the body. In main, where we called the area function and passed rect1 as an argument, we can instead use method syntax to call the area method on our rectangle instance. The method syntax goes after an instance. We add a dot followed by the method name, parentheses, and any arguments. Okay. Small question that I have is, can we have multiple implements blocks? Area 2. Sounds like we can. Yes, you can. Okay. In the signature for area, we self. Within an implement block, the type self is an alias for the type that the implement block is for. Methods must have a parameter named self of type self for their first parameter. So Rust lets you abbreviate this with only the name self. In the first parameter spot, okay, let me reread because I'm not sure I have grasped the full logic. Methods must have a parameter named self of type self for their first parameter, so Rust lets you abbreviate this with, okay, it's like in Python basically. To be honest, I hate this pattern to always need to add the self in the method name of a class to be like to say that this method is part of the class. But I can see why, like the other way would be to have like, actually I'm not sure, like what would this mean? Expected value found module self. Let's say I'm returning 4. Like, what can I do with area? Like, can I call area like this? Or maybe I should, oh, maybe it's like a static function. Okay, maybe that's, I'm not sure actually. Or maybe it's to scope the function to just functions used outside of or inside of rectangle. So for example, if I had compute area with type user32 and height user32, I could have this compute area yes, it would be static function. And static functions are called by struct name function name with columns. Struct name, column, function name. That actually makes a lot of sense. So now if I have actually, let me just return integer. I just have an integer. I just want to verify to make sure that I'm not showing a rectangle. Okay. Interesting. Okay, then it's not too bad to be... Okay. I guess the question now that you should have is, or that I have at least, is are we usually more frequently writing static methods that should be inside a struct type, or are we mostly writing methods in a strong type? Because if we write most of the time this type of methods, so methods that are using attributes of a struct, then it's like more work to always add this and self than prefixing a static method with the keyword static. Otherwise, if we write more static methods, then it makes sense to prefix with nself. But from my experience, I would say that I write more frequently internal methods for a struct than static methods. So, not sure. 90% of the time you are writing nself functions, exactly. So I would say, okay, I guess you can do the argument that maybe we should have instead the static keyword and the nself, because we would write more frequently nself if we had nself than static. But maybe I'm not sure why they decided to go with this way. How the creators thought about this. At least it's explicit. Like I know that, yeah, actually that's a good point actually. Like I know that in Java, for example, I love always have this keyword, and I hate when people do not do it, because I really like the fact that when I have this, I know that this is part of the attribute class. So it's I'm referring to an attribute and not a value that I could have computed 10 lines below in the function. So let's say I had yeah, I love using self or this, exactly. But yeah, I guess it's more I know C++ allows to leave this out, yes, and it's the same in Java. It's optional. And it is so confusing. I would not say that it's super confusing, or at least probably confusing when you try to read the codes, but it's not like it's not a standard. And so since you have the option to do both ways, you get some inconsistencies in the code, and usually it's not nice to have inconsistencies. And also, like when you, yeah, it can also lead to bad practices. That, let's say you have it's unnecessary mental load for the reader. Exactly, yes. That's one argument, and the second is that you can get you can get confused pretty easily if someone creates a new variable with just one character is changing. Like, let's say it's like R1 that is part of this or self, and then someone is creating R2 from R1. But here R1 is not is an attribute, and it's not something that you created after. But imagine that you have like 10 or like 3-4 variables with the similar name. Then it's pretty confusing to know which of these are attributes and which of them are not. So I guess I can now see why the self is useful. 100%. It's more about why do you need to add the self inside the parameter of your internal functions. But I guess it's a choice, and it's not a too bad choice. To define the function within the context of rectangle, I think I've read this part, this too. We have chosen endSelf here for the same reason we used endRectangle. In the function version, we don't want to take ownership. In the function version, we don't take ownership, and we just want to read the data in the struct, not write to it. If we wanted to change the instance that we have called the method, oh god, it's so that's probably the reason why you need to have a self, because then you need like you have the ability to specify if self is mutable or not. Okay, now I understand why it's useful. Having a method that takes ownership of the instance by using just self as the first parameter is rare. This technique is usually used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. The main reason for using methods instead of functions, in addition to providing method syntax and not having to repeat the type of self in every method's signature, is for organization. The main reason for using methods instead of functions, in addition to providing method syntax and not having to repeat the type of self in every method's signature, is for organization. We have put all the things we can do with an instance of a type in one implement block rather than making future users of our code search for capabilities of rectangle in various places in the library we provide. Note that we can choose to give a method the same name as one of the struct's fields. For example, we can define a method on rectangle, also named with fnwidth. That's interesting. So you can have this a function inside an implement block with the same name as an attribute of your struct. I guess it's the same. Is it the same? I guess it's different. It's a different concept than shadowing, but it seems a bit similar because you have the same name for a different thing. I guess it can be seen as a shadowing. It's just that instead of having a different data type, it's a function that is using the same name. Here we are choosing choosing to make the with methods return true. If the value in the instances with field is greater than 0, and false if the value is 0, we can use a field within a method of the same name for any purpose. In main, when we follow rect1.with, with parentheses. Rust knows we mean the method with. When we don't use parentheses, Rust knows we mean the field with. Interesting. So one question that I have now is, can you also reference, wait. Can you also reference the with function like this, with the column operator? Wait, what? Rect1. It can. Nice. But yeah, I think this is much more clearer than this. Wait. So if we have another function, that is not, wait, that is not an internal wait, okay. I'm wondering if we do not have the n self. So let's say we have fn with, that is taking a with, missing type to the, okay, u32, duplicate definition, or let's say height. And there I'm plugging rect1.height. That works. And what if now I'm calling, like, can I access height from an instance of struct? No, I think I need to have the n self like this for it to work. Wait, why is it not working? Cannot find. Okay, that makes sense. Here we are choosing to make the with method. Okay. Often, but not always, when we give methods with the same name as a field, we want it to only return the value in the field and do nothing else. Methods like this are called getters, and Rust does not implement them automatically for struct fields, as some other languages do. Getters are useful because you can make the fields private but the method public, and thus enable read-only access to that field as part of the types public API. This is equivalent to say that we encapsulate the attributes. Encapsulation. We will be discussing what public and private are and how to designate a field or method as public or private in chapter 7. From what I remember, you need to prefix with pub or priv, yes, priv. I have no idea. PR maybe. Like for example, if we go to LeetCode, a LeetCode problem with Rust, we will see that it has the pub keyword. Or actually, let's ask ChatGPT how to do it. How do I make a struct attribute private in Rust? Attributes. In Rust, you can make a struct attribute private by starting the name of the attribute with a lowercase letter. By convention, attributes starting with a lowercase letter are private and can only be accessed from within the same module where the struct is defined. Okay, so this means that these two fields within height are private. This is wrong. Yes, yeah, this is wrong. The answer of ChatGPT. In the example above, the struct myStruct has an attribute secret field. Someone in my Twitch chat is saying that your answer is wrong. Struct fields are private by default, no matter the spelling. But I am not perfect. Please provide more context. Norom, my viewer, is saying that all attributes of a struct are private by default, no matter the spelling. All attributes of a struct are private by default, no matter the spelling. Yes, you are correct. I apologize for the mistake in my previous answer. In Rust, all attributes of a struct are private by default, regardless of the spelling of the attribute name. To make an attribute public, you need to start the name of the attribute with an uppercase letter. Here is an example. Alright, let's flag the not correct response. This isn't true. Attributes in Rust are private by default, no matter the spelling. Submit feedback. Awesome. We improved ChatGPT. I love how confident it is in being wrong. Exactly, yes. But yeah, I'm not sure like how